All right, let's do another coding challenge today. And again, this one's from Code Signal again, and I'll put a link to it in the bottom. Again, one of the things that I like about Code Signal, the way they approach this is, they give you all of the information about kind of the project and kind of the requirements. They give you some examples, and then they give you these kind of tests. So they're some of them are blind tests. Some of them you don't know the inputs to, and some of them you do know the inputs to. So at the end, you can click run the test, and it'll kind of tell you if you pass or fail. So this is the starting point of the solution. Let's go ahead and look at this. So this one's called is admissible overpayment. One of the things I usually like to start with is I just like to print what we're given here. So let's print these out. When you run the tests, none of them will pass, but at least you'll be able to open this up and you'll get a chance to kind of see. So the input values here, in fact, you don't really need to console out because they give you the input values. So prices is an array of 3 elements, it looks like. So you can see that there. Notes it's an array of 3 elements, and each element has a string kind of in this format. All right, so if we look a little deeper here, it looks like this middle thing, the notes, is kind of it's an API response. So we can kind of see some examples there. And that informs the users when the price of an item is different from the one in the store. So here, 10% higher than in the store, 5% lower than in the store. And it looks like this variable X is the amount that the user is willing to overpay. So it looks like we get this array of prices, and then we get this array of kind of notes that go for each of the prices. So 110, this indicates that 110 price is 10% higher than in the store. And so, and 95 represents this is 5% lower than in the store. And 70 is exactly the same price as in the store. And then at the end, the user is willing to pay at most kind of 5 over the store price. Okay, so first thing I want to do is just loop over prices and notes and see if we can kind of extract the information that we're going to need for them. So okay, so I got the price and the note, and then I'm going to just create this in-store price. Don't know what that is yet, but I'm going to set it equal to just the price right now. All right, so now I need to be able to parse that that notes up a little bit here. And so what I think I'm going to do is I'm going to use the assumption that a percent character is in the string. And if I find one in the string, then I know it's either a percentage higher or a percentage lower than the in-store price. Okay, so let's just see what we have here. So I'm going to say note parts. I should have so I've got the note and the parts here. See, I've got it split up now, 10. And so in this last one, I only got 1. But if I get 2, then I know there was a percentage sign in there. So that's what we're going to key off of. So now if I'm into this loop, I know there's a percentage sign. So it looks like the first value in this array will always be the percent. And if this format is strictly true, I know lower or higher are my keywords that I'm probably going to look for here. And so maybe if I see the keyword lower in the second part, then what I'm going to do is my percentage is really the negative because it's really going down, right? Just a little check here. Let's print parts and percent Let's see if we get what we think we're going to get. All right, so I got 10 and plus 10, 5, and it says lower, so I'm thinking it's minus 5%. Okay, so if I find those things, what that means is now I can adjust this in-store price to account for the percentage that we're giving off here. All right, so let's think about the formula here that we're going to have. So if we look at the numbers here, this is the first one. It says the price is 110, and then the note says this is 10% higher than the store. So the price in the store should be 100. So, all right, so given that, like if you were going to calculate that price that we're given, which is the 110, what we're saying is that's going to be the in-store price, which is 100, times 1 plus this percentage, and that percentage is in like a percent, so you have to divide this by 100. So that's the formula, and we want to reverse this formula to find the in-store price. So I'm going to do this in parts. I'm going to create the factor, which is going to be 1 plus percent divided by 100. And so then the in-store price will be the price divided by this factor. Okay, so let's see what we have here. After this whole thing, we should be able to adjust this in-store price. So let's say price, note. Oh, I want to print these out. So let's just do a little printing here. Price, note, in-store price. Make sure we're getting what we want. So 110, 10% higher, and I got essentially 100. 95, 5% higher or 5% lower, and so the in-store price is 100. And then if I don't find the percent, it's the same price. So I think I have what I want here. Okay, now I'm inside this loop, so what we're doing is we're finding the in-store price for all of these. And I want to track the total price. We'll initialize it to 0, and then I also want to track the total in-store price. So here I'm going to know total price, whatever that was, and then the total in-store price. And then presumably I should be able to subtract these two and use my price sensitivity and determine if this customer is going to be okay with this purchase. So if total price is less than the in-store price, then presumably we'll return true all the time. Otherwise, we're going to calculate how much we overpaid. And then we're going to return true if overpaid is less than or equal to X. All right, let's see what that works. Okay. So we're passing some of these. Let's dig into the ones we're not passing. So let's print some of these variables. So 213 was my total price. 210 was my in-store price. I overpaid. Did I get this wrong? Yeah. I did it wrong here. It's gonna do it that way around, I think. Okay, so we're passing now that one. Let's look here on test number 4. So the total price was $220. The total in-store price was $99. $120 was the total overpay. And it looks like 120 was what it took. If overpaid is less than or equal to X, it's like a rounding error here or something. So this looks like what I'm dealing with here is like a rounding. It's like a 120.00001. So we're dealing with some floating point issues here. So what I think I'm going to do is go ahead and just round this. Let's see if we can put this rounding issue to bed. Okay, so now we got past that one. Okay, so here's one. They put price sensitivity as 0. What does that mean? So 160, 159.999, and 0. And I returned false, and it's expecting, no, I returned true, and it's expecting false. Okay, so this is a bit counter to what we just did with that rounding. So it looks like my overpay, it got rounded to 0, which matches my value of price sensitivity. And so then I'm returning true. But you can see here, they kind of snuck this really low percentage in there. So the true value of overpaid is not the rounding one in this case. So what if I take this off again? That's going to make the other test fail, but let's see if we can figure out a different solution. So that's this one, right? So 120 is my price sensitivity. And I got 120.00001. So that one failed, but now my other test passes, right? Test 6 passes. Kind of caught in the middle of this, isn't it? So it feels like I want to round it at least to the cents, but even if I round to cents, that's going to be 0. This is going to pass. All right, so I'm going to put the round back on there. All right, and then maybe we need a different thing here to make this pass. You know, maybe what we need to do is do this. And I don't think I need this, right? Because I think this overpaid is always going to be, it'll be negative. I think I can get rid of this check. Let's test that first. Okay, so I'm back to kind of still where I'm at here, so I don't think I need that. But I think what I need to do is right in here, at some point I need to go overpaid, and I need to round this. And that should make test 4 pass. But here, if X is equal to 0, this feels ugly. And overpaid is greater than 0, then I want to return false. This feels like it's a special case here of some floating point deviation that's really super small, but I can make that test pass. That makes all the 10 tests that I get pass. If I submit this, it looks like even the hidden test pass at this point. So at this point, the 10 sample test pass, and then also the 10 hidden test pass. So this is a solution that will function. This feels a little bit icky, but it seems to work. One of the things I do like about Code Signal is after you've completed your solution, you've kind of passed all the tests, they do show you what other people are doing. And so you can see kind of the solutions from different languages and how many characters each of these things take. So for example, if I look at this coffee one, I'm not necessarily familiar with coffee, but there's the solution in coffee. Here's a Ruby solution. We can go and find a Python 3 solution, and you can see kind of the winning Python 3 solutions, 91 characters long. So that's the bit of code right there. Now, it does absolutely 100% win this contest, because this contest has certain rules about, it's trying to minimize the characters. Whether this is the best code for maintainability, I would say no, probably not. I'm not really liking this eval here either. And then what you can do is you can look at other people's solutions and kind of learn from them. If we skip down a little bit, here's 129 characters, starting to get a little more verbose. The variable names are still kind of tiny. If I go to page 2, 145 characters. So this solution is pretty small again, but again, the variable names are pretty tiny. Here's one where only 3 lines of code, but 190 characters. All right, here's one. It's 205 characters, and I can see, the variable names are still only single digits, but I'm starting to feel, a little bit more maintainable to me. Again, I think that's a nice short kind of coding challenge for the day. If you have comments, leave them down below.